Welcome back to the Ubuntu Server Series. Today we're going to talk about clouds and containers. Now there is so much I could talk to you about with clouds. I think that we're going to actually follow up before too much time with an entire series on cloud computing, maybe with Ubuntu or especially with Linux, and it's just going to be awesome. So I'm going to touch on conceptually what's going on in the world of cloud computing in Ubuntu, specifically in this nugget. But I don't want to have a nugget that's just me lecturing to you and writing in bad handwriting on a whiteboard. So we're actually going to set up a Linux container, which is something that's often done in the cloud, and I'll talk about that when we get to it. But basically, this nugget is about clouds and containers. So let's go and put on our thinking caps a little bit and talk about cloud computing in the world of Ubuntu. So when we talk about the cloud, I'll be honest, for the past few years, I don't know when the buzzword first was invented, maybe 5 years ago or so, the cloud really annoyed me because it was a word that people used for anything that had to do with abstracting services. Well, now we're to the point where we can actually define the cloud as something a little bit better. Things like software as a service or platform as a service. And there are a few key players, right? Amazon Web Services. Jeremy Chara just finished up a series on Amazon Web Services. It's amazing, it's powerful, and it has a set of APIs that is well known and people have been using for a while. Amazon Web Services is not going anywhere. So we talk about Elastic Cloud Computing, their S3 storage, all of these things. Along with, they have the database service as well. But these are powerful, well-known businesses are using the ability to expand and contract their infrastructure. It's awesome, right? Cloud computing is a real thing now. It's not just a buzzword that I find annoying. It's powerful, and along with that means that while Amazon has certainly made the playing field huge, there are other competitors. There's things like OpenStack, because with Amazon, every bit of your data ends up in the public cloud. Now that's not necessarily a bad thing, and the economy of scale means that Amazon can offer incredible pricing on powerful server instances. But there is an alternative as well, OpenStack. OpenStack is what Ubuntu uses. It's an open infrastructure for producing your own cloud computing. There are others, right? There's OpenStack, CloudStack, there's the HP Cloud, there's Microsoft, they do their own. There's Eucalyptus. Now Eucalyptus uses a lot of open source stuff. There's some proprietary stuff in there. Ubuntu actually used to use Eucalyptus as their cloud platform, but back in 2011 they switched to the more popular and more open OpenStack. So what does this mean? What is OpenStack? Well, let's say that you wanted to start your own Amazon company. Well, you couldn't use Amazon Web Services because that's their product, but you could build it on your own servers using something like OpenStack. And that's what Ubuntu allows us to do, create our own private clouds. It's really amazing. And companies can create their own cloud and then resell that cloud so that you can be your own tiny little Amazon, or not even tiny. You can be a huge company providing cloud services to people, but using Ubuntu and OpenStack as your underlying cloud service that's actually running on your hardware. Now, I talk about Ubuntu. Of course, that's not the only operating system that you can use to install your cloud, but this is the Ubuntu series, so that's what we're talking about. Now, Ubuntu and Canonical, the company that creates Ubuntu, has done an incredible job of focusing on implementation. That's what made Ubuntu popular in the first place. They took Debian Linux, which was powerful and awesome but really difficult to install, and they made the installation process awesome. Well, now they're doing the same thing with cloud computing. They're focusing on getting the implementation down so that I use the word voodoo, but taking the voodoo out of setting up a cloud infrastructure. If you have to hire an entire team of people to set up your private cloud, you're not going to save any money because you have now a whole a whole crew of people that's going to do it. But Ubuntu's focusing on making it possible to implement a cloud without the need to have highly trained specialists. People like you and me are going to be able to install an entire cloud infrastructure. And then Ubuntu went one step further, and this is actually really cool. It's like magic, and that's why it's called Juju. Juju actually further abstracts the idea of cloud computing. And what they do is Juju provides charms, and to visualize them, they're just like chunks of data, like scripts or something. WordPress is usually one that's commonly used in examples. And basically, you tell Juju, I want to install WordPress. As long as Juju understands your cloud infrastructure, whether it's Amazon Web Services, your own OpenStack cloud provided by Ubuntu, whatever it is, Juju doesn't just work with Ubuntu clouds. It works in, with all of the major cloud hosting providers. Juju takes the difficulty out of installing applications. So not only have they abstracted the idea of servers, installing servers and operating systems, now you can say, hey Juju, I want WordPress. Here is my credentials and my information for my cloud service provider. Here's my, Amazon login name and, all that sort of stuff. Here's my S3 storage. I want WordPress installed. So you just simply with like 2 or 3 command lines options, you tell Juju, install WordPress, install MySQL, connect them together, and all of a sudden, bam, you have a working WordPress installation. Juju, again, tries to make it so that we don't have to have highly trained teams of specialists to do our computing. The whole idea of cloud computing is to move the complicated stuff outside of your responsibility, and that's what Juju provides. So, Juju's awesome. OpenStack is awesome. And the thing I really like about it is that Ubuntu is not trying to reinvent the wheel, right? They're using OpenStack, very popular. Other operating systems are using OpenStack, right? You can install OpenStack on top of other Linux distributions. And one really powerful thing is they're using Amazon and Rackspace, all the common APIs that exist for the large public cloud infrastructures. OpenStack implements them. So switching, like let's say you have a huge Amazon Web Services infrastructure that you have out there. It's huge, it's enormous, and you really wish that you could transfer it to your own private cloud hosted on Ubuntu and OpenStack. Well, since it uses the same APIs, that transition is much easier than if it was an entirely new system. So, cloud is such a hot topic now, and it's interesting now. It's not just an annoying way of saying abstracting services. There are things that Ubuntu does, like Metal as a service. This is actually a new thing that I find fascinating. In the cloud, you can actually spin up, so you have your giant cloud of servers here, and you just like spin up an instance of a server, right? So like you have this virtual server that's just like taken out of this giant cloud. Well, what MAS does, or Metal as a Service, it kind of does the same thing, but for actual hardware. You install a bare minimum MAS installation on the actual physical servers. So these are physical servers. And then you can add the physical server or take the physical server away from your bare metal clusters. It's like hiring a digital person to go in there and unplug the network cables or plug them in and spin them up or spin them down. But instead of spinning up and spinning down virtual instances, MAS will actually spin up bare metal for you. It's kind of a cool concept. And then, like I mentioned, Juju earlier, which allows us to install applications seamlessly. Juju actually reminds me, if you've ever done any of those like portable apps or any of those things where the entire installation process is contained within a single download, like VMware, like you can get application containers or whatever, things like that. That's what Juju reminds me of, except that it configures it all in the cloud environment and does all of the configuration and connection and spinning up of required servers behind the scenes. So OpenStack cloud computing in Ubuntu is amazingly powerful, and obviously it's something that could be an entire series, and I hope it is pretty soon. The entire, talk about setting up an entire cloud system and how to add servers, take servers away, use this MAS system to add servers to the cloud and take them away. I hope that there is a series for that. But today I actually want to demonstrate something. I don't want to just leave you hanging with all this, enticing information about cloud computing. I actually want to show how to get a Linux container installed, because Linux containers, let's talk about that for a second. So let's talk about the difference between a virtual machine and a container. So here in my sort of sad drawing, this is the Linux machine, okay? So this is like our Linux machine that we have been working on for this whole series. Now there is a layer of hardware virtualization. And now for us, in our last NuGet, that was KVM, right? This is the layer that creates virtual hardware on which these individual systems are installed. So these systems see virtualized hardware. They install completely on a virtualized set of hardware. Now, this means that it's far more flexible. This PC could be Windows. This could be Linux. And with a little bit of hacking, this could be OS 10, but we probably shouldn't really say that. So this this can be Unix, we'll say. So it's more flexible. However, because of that hardware virtualization, it also has more overhead. Now, in modern virtual environments, we can do things like overcommit memory and overcommit storage. So we're actually gaining a little bit of ground over the, how virtualization worked at first. You used to just carve off a hunk of the resources and dedicate it to a PC. Now virtualization is getting a little bit smarter, but there is still that whole layer here of hardware virtualization. So then we move to a Linux container. Now this is conceptually different. Basically, you take the Linux operating system and you carve off a hunk of it. But it's not as if we use that hunk like we did over here and create a whole new system. Basically, this Linux environment is really just using all of the programs, the kernel, the actual running kernel of this Linux operating system this container is using. So this is a lot like a chroot or a jail, if you've ever heard of a system jail. This functions as a full PC. It doesn't see the activities of the other containers. However, it just is running on this Linux operating system. The Linux kernel allows for that isolation of the different containers, and it means extremely efficient use of the resources because they're actually using the same running kernel. Shared libraries that are like loaded into memory, they are sharing. They're super efficient that way because they're running on the same system. So yes, it's faster, it's leaner, it shares the resources, not just like overcommitting like a modern virtual environment can do. When I say shared resources, I mean like if there's shared libraries and RAM, both containers can see it because they're using the same RAM. It's really powerful. There are some limitations. You can't use Windows in this type of environment because it's actually running the same Linux kernel, right? So a Windows, this couldn't be Windows because Windows can't function with a Linux kernel as its running kernel. So Windows isn't possible. However, you can carve off a little container of this environment and it functions as a fully standalone Linux instance, but it's just a container inside a fully running operating system. And this works really, really well. It works really well in the cloud. So this is something you can carve off an instance and provide, a complete separate environment that's isolated from the other environments, and it's just a container. It's not an entirely new instance. So conceptually, that's what's going on. Now, I said that they're great for the cloud, but they can be implemented anywhere. We're going to install a Linux container right here in our test environment. Like I mentioned, it can't be Windows. It can only be Linux containers, but that's by design, right? There's no way for a Windows computer to share the running kernel of a Linux device. That just doesn't even make sense. So it only supports Linux, but that's by design. And now Ubuntu, here's a key. Ubuntu can run other distributions as containers because the Linux kernel is common between different distributions. However, when we install a container, we're going to use a template, and the Ubuntu template is the most mature and robust, which makes sense. The Ubuntu people, the canonical crew and the people in charge of developing Linux container implementation on Ubuntu are going to focus on making containers that are Ubuntu. So the two best templates, or the two maturest, most reliable templates, are going to be Ubuntu and Ubuntu Cloud. Now, what's the difference? Well, Ubuntu actually installs just an Ubuntu system in that chroot environment, or in that Linux container environment, whereas Ubuntu Cloud actually goes out and pulls a fully already set up image from the cloud and expands it onto your system, whether that's a local system or a system like in Amazon Web Services or OpenStack or wherever your cloud environment is. And do you like how I keep saying, whether it's Amazon Web Services or OpenStack, the whole idea with cloud computing is that it shouldn't matter where your cloud infrastructure is. As long as it's using common APIs and using standards, you should be able to implement your things anywhere. And Ubuntu is focused on that concept. That's why, it uses Amazon APIs and stuff in OpenStack computing. Nonetheless, we're actually going to set up a container because this has been a long talky nugget where I've said a lot of stuff and underlined a lot of things. I actually want to do something. So let's go set up one of these Linux containers in our system, and you can see kind of how it works. It's pretty slick. Now, I have to be honest, not too many releases ago, it used to be really complicated to set up Linux containers in Ubuntu, or anywhere for that matter. But Ubuntu constantly focuses on making the installation and configuration of things simpler. That's why I love Ubuntu so much. So, for example, what used to be, a good half day of Googling and trying and failing to get Linux containers working, here's all we have to do. So I logged into our CBT server, sudo apt-get install lxc. Hit enter, and that's all there is. Now, what's going on behind the scenes? Well, it has to set up a virtual bridge, or actually not a virtual bridge. It has to set up a network bridge so that our containers can actually communicate over the network back and forth. It sets up DHCP specifically for those internal containers. It sets up an entire new network subnet specifically for the containers that we're going to create, all with that simple apt-get. So we've installed Linux containers. They're up and running. Now, if we want to actually create a container, which is going to be like a tiny distribution running inside of this, but sharing all the resources, we have to simply type sudo lxc. Now, if you want to see all of the container commands, just hit tab a couple times here, and you can see all of the Linux container commands. They thankfully all start with lxc, which is really nice. I prefer it when they follow a standard like that. But in order to create our test container, what we're going to do is lxc create. Remember, we have to be root here. And then -t for template. Now, what template are we going to use? Well, there are a handful, but the ones that are very well supported are going to be Ubuntu and Ubuntu Cloud. We're going to use Ubuntu because we're not actually implementing this on a cloud instance. We're actually just putting it on our local server. So I'm going to do -t Ubuntu for the Ubuntu template, and then -n, I have to say, what's the name of it? Well, let's call it test, okay, for no other reason. So that's all I have to do. Now I type that, and it is actually going to go through and create this entire Linux container that's going to be a full operating system. It's going to set up the root file system, and it's actually telling us where it's going to be stored on our local file system, right? It's not going to be like an image file, like a hard drive image, like a virtual machine would have. Remember, we're using the same system, so it's just going to be a folder on our system where the root file system of this container starts with. The default user is Ubuntu with the password of Ubuntu, so that's really nice. And we can actually start and connect. Up here, I actually did this so we could look at all of these commands. This is a trick, and this is kind of a bug in the current version of Ubuntu. Maybe it's solved in more modern versions, like in the 13.04 version or something, but it's not a big deal. Basically, when you start the container, so right now the container exists, but it's not started. I don't want to say booted because it doesn't really boot up, but it activates, right? It goes live. And the way to do that is to type sudo lxc start -n, the name of our container. What do we name it? We named it test. And now if I do this, it's going to drop us directly into the command shell for that container. So it's going to like switch. So all of a sudden, bam, I'm connected to the container. So what I'm going to do is do the -d flag. I recommend you do this when you start your container. So do a -d, and that's going to put it in the background. It's going to daemonize it so that now it's running without our interaction. So right now we have a container that's running. Well, how do we know that? Well, we could type sudo lxc list, and it's going to show us what we have running. So how many containers do we have running? Well, we have one named test. There are none frozen. There are none stopped. So we know that it's running. How would we connect to it? Sudo lxc console -n for the name test. So what we're doing here, we're using the lxc console to connect to the test container that we just created and started up. And then you'll see here all of a sudden this is turned into a login to our test machine, and it's going to function just like a machine. It said the login was Ubuntu with the password of Ubuntu. And now here we are inside of our fully functional container. So this is not really virtualized. We're actually sharing all of the things with the parent operating system, if you will. So if I do df-h, we can see that right now the root of this hard drive, the root is 19 gigabytes in size, 14 gigs free. Let's connect directly to CBT server and see what we have here. See here, the root drive on this is 19 gigs in size with 14 gigs free. It's the same hard drive, even though this is functionally a completely different system. We can show it's different. Let's look at the Ethernet port. ETH0 here has an address of 10.0.3.110 instead of our 192.168.1.80 that we know that the underlying system has. So thanks to that bridged interface that it created here, this is the bridge that the Linux container system made. See the IP address here? So thanks to this bridged Ethernet port, this containerized, if you will, instance can now actually do things like ping and actually resolve and get to the network. So this is a fully functional instance of Ubuntu, and it's running inside of our regular server, but not virtualized, sharing the same resources. It's fascinating stuff, and this works really, really well on the cloud. So I'm going to pretty much stop there for now. Oh, to disconnect, it's almost like a screen session. Control-A-Q will actually disconnect us from that instance. Now, from that container. It's still running, but we're just not connected to the console. In order to connect to the console, we would type the same thing, and then we would get back that virtual console, or the console of the container. All right, so Control-A-Q, and that disconnects you. If we hadn't daemonized the system when we first started the container, we wouldn't have been able to disconnect. That's the bug I talked about in Ubuntu, where we would connect to the console, but we wouldn't be able to disconnect. That's just kind of a bug. But that's how containers work in Ubuntu. We can set up several containers. All of those different commands that I showed you, obviously you can play around and check. You can freeze an instance so that you can just like hold it in suspended animation and restart it on your at will. This is kind of a neat thing to play with. LXC start ephemeral. What this does, it starts the instance, but when it stops, it discards any changes that were made. So it kind of just like starts it in snapshot mode. You start it just like it is, and any changes that you make disappear. So that's kind of cool. Linux containers are powerful. They're slightly and subtly different from virtual machines. So the important thing is to understand the difference between virtual machines and containers, and that should help get you on your way to understanding when one might be appropriate and one would not be appropriate. Containers, again, work really good in the cloud. That's nice to know. So in this nugget, we covered containers. We actually built a container and interacted with that container on our server. It's actually still running. I didn't stop it. It's running on our server right now. There's more you can do with containers. I urge you to look into that. And like with every nugget, take what we learn here and extrapolate, right? Study some more and play with it until you get really good at it. Cloud computing, I touched on a lot of concepts, and I know that that's frustrating because I want to teach you all about clouds as well, but this nugget's already probably longer than it should be. But the important thing to know is that Ubuntu uses OpenStack now as its cloud infrastructure, providing as its cloud infrastructure. That's the technology that Ubuntu now uses. They used to use Eucalyptus, but they no longer use Eucalyptus as their cloud infrastructure. So OpenStack is what's currently used. And then just know that Ubuntu is now, or Canonical and Ubuntu are now providing all sorts of really cool things like Juju and Metal as a service, and really neat things for the cloud and for the cloud world that I think are really going to be important in the future. I hope that this nugget has been informative for you, and I'd like to thank you for viewing.